Hi, welcome to the Planetarium, UTA Planetarium live stream. Today I'm not in my office. As you can see, I'm orbiting around Earth. And this
What?
should tell you something because this is going to be a special program. Tomorrow is Earth Day. So we'll talk about what is Earth Day, how it started, and we'll talk about the importance of protecting our great planet. So I'm just came back to my office again, and here's a
Back
nice
to the office.
back to the office.
You got some Earth stuff in there. Yeah.
I do,
Definitely.
certainly. So let's start with our planet. If anyone not familiar with our planet Earth, so let's take a look at where is it located and why it is important. So here is our Earth from space. And we all know that, this is just a beautiful Earth, has a night side and it has a day side. And there are continents, great civilization on the surface, and 75% of our planet is covered by liquid water. This is a very unique thing for our planet because not every planet have that opportunity or having access to liquid water. So where is it located in the solar system is important for our planet. So here is the order from our star, the sun. Well, the Mercury is so close to the sun, so it is pretty much cooked by the extreme amount of sun's heat and light. And the second comes Venus, and Venus is what we call troubled planet because it has thick clouds. And even though it is the second in the order, the Venus is the hottest planet in the solar system. So if you are wondering how hot it is 900 degrees approximately on its surface. So it's not a great travel destination. If you booked a flight ticket to Venus, go ahead and cancel it. You will be
What?
cooked.
Venus isn't a good place to travel? What are you talking about?
I don't know. I think you've been there last summer,
Oh,
right?
yeah. What about the clouds? I mean, there's talk. There's talk about maybe a cloud city where you could put humans in the clouds. That the pressures there aren't too bad. Maybe there you could somehow safely put some oxygen. Like, it's possible.
Well, if you remember on one of our previous live streams, the one of the first lander, actually the first lander and the consecutive landers, they failed because the engineers never thought that the conditions were that extreme on the surface of Venus. So the electronics melted down on the landers, and the landers itself, they crushed. The extreme pressure and extreme heat is making Venus is very, very tough planet.
Definitely not a place that I think most of us would ever want to be.
And here is the reason for the Earth Day. Earth Day is one of the main objectives are we don't want to become like Venus. We'll talk about how it became like Venus. Anyway, the Earth is the third from the sun, and it is what we call habitable zone. This zone or this distance range is where liquid water can exist. So water actually exists on planets and it is very common, but usually in an ice form. So ice water is not very useful for at least a life that as we know of, the species like us, we need liquid water to live. So here Earth maintains it. And what else maintains it? Mars. Well, Mars is on the edge, but still we can kind of say it is close to the habitability. But the problem with Mars is Mars doesn't have water, at least on its surface. For now, we talked about these Mars and Mars feature exploration too. Maybe there is water underneath. So hi Kurt, by the way, says floating cities on Venus.
Kurt's bashing my floating cloud city on Venus.
Oh,
right?
floating cloud, like in the
I don't know why you're doing me like that, Kurt. I thought it was a good idea. Okay.
All right, so
Anyway, we should talk about the founding of Earth Day, right?
yes, Earth Day is tomorrow, by the way, not today.
Yeah. Oh, yes. Yeah, it's tomorrow. 22, April 22. 1970 was the first one.
Yes, and do you know how it started?
I can show them.
Well, there's a long story, but the one of the good roles of like one picture actually resulted a chain reaction to start the Earth Day. Do you know what picture that was?
I have better than the picture, Levent. I have better than the picture.
Okay, so the picture was actually the what we call Earthrise, a picture taken by one of the Apollo astronauts from the surface of the moon. So not from the surface of the moon, but from the orbit of the moon. So in space, from the window of Apollo spacecraft, they took that the Earth's picture, and that was Earth's very first picture from space.
Well,
So
taken by a human. Yeah.
taken by human, right? I mean, and also you need to be at like some certain distance to take a good shot of the Earth in as a whole. So they took that picture and sent it to Earth. So that was the first time they were looking at a great image of Earth. So it looked round, of course, not flat, right?
Yeah.
So that proved that our Earth is in a great round shape, and also it looked beautiful, and it was probably on the covers of many.
What's so crazy about this photo, which we'll show shortly, is that when Bill Anders, the astronaut who took it, when he was taking these photos, he didn't really know anything about cameras. NASA just hands him a camera and was like, yeah, you got to take all these photos while you're up there. And they called him like, hey, you're on the backside of the moon. This is not an area of the moon we get to see very often. So we need you to just start taking photos. So as they're passing around the moon, we're actually doing it right now. This is how they would have seen it behind Levent here. This is an actual simulation of what they would have seen verbatim. So as he's coming around into the lit portion of the moon, this is the backside where we don't usually see. He's just taking photo after photo after photo, looking at craters and so on and so forth, trying to get some topography. And then as the sun, you guys are going to see the sun come over Levent's left shoulder. As it moves out of frame, he starts to notice the Earth rising up. So shortly the Earth will pop up. I'm going to get off the screen so that I'm not in the way, just in case. And when he sees Earth pop up, he's like, I should get a photo of that. So let's wait so very patiently for Earth to pop up.
And I remember seeing the actual footage of this and also the pictures. So it's really good looking moon. And here is Earthrise. At that moment, yes, they capture that photograph.
Yeah, it starts taking pictures, and we can zoom in just a little bit, I think, to make this look a little bit better. So he sees the Earth, and he takes a photo, and he sees something that looks like this, which we can show you the real photo here. Momentarily, be patient with me. Forgive me. There we go. That's the real one.
Yeah, that's a real Earthrise photo.
Taken by William Anders. I can drop a graphic
From the Apollo
there.
8 flight.
Yep.
Apollo 8 was another test flight that orbits around moon. It didn't land on the moon. And it orbited around the moon, so they were still doing the final tweaks for the Apollo 11 lander.
The picture was actually taken on December 24th, so Christmas Eve.
Yep.
How nice.
So after that photo, not immediately after, but that photo started thinking of what a beautiful planet that we have. And also, are we doing good enough to protect it? And then all the Earth Day started, and later the Congress formed Environmental Protection Agency, what we call EPA, and a lot of the things were done, or a lot of laws were passed to protect our Earth. And we are still thinking about, we are transitioning to the electrical vehicles, solar power, wind power as much as we can, and we are trying to like use clean burning natural gas if we just need to use combustible gas.
Yeah, yeah. I mean, part of NASA's whole goal is Earth sciences, right? They manage in coordination with NOAA and USGS. They actually manage a whole bunch of Earth science stuff specifically. So I can pop myself off the screen here. You guys don't need me in this, but this is a view of all of the Earth science specific satellites that NASA, NOAA, and USGS manage to study the Earth.
That's how we know, like based on scientific data, the cloud coverage, not only the cloud coverage, that's for forecast, but the ice coverage. And the like, if anything changes on the surface of Earth, for example, after a big earthquake, the plate tectonics and everything. So with those satellites, we get all the data from our planet, and we would like to know exactly what's going on.
This is just a list of all the current spacecrafts that NASA works with, and some future ones too. But it's just it's tremendous.
And also, you know, the reason that when we look at other planets, why we are so concerned about future of our planet, like for example, we said, you know, the Mars is even if it is considered in the habitability zone, there is no water, but that was not always the case. So Mars was not big enough to hold water on the surface to start with, because Mars is a small planet and the Mars air is pretty thin. For that reason, the air pressure is very low on Mars surface, so water escaped from Mars. So this is what happened to Mars. But when we look at Venus, the size-wise, Venus actually looks like Earth. So it could be other Earth, but it is not, because the air on Venus doesn't allow the planet to be like Earth, because the air on Venus have a lot of carbon dioxide, what we call emission gas in our planet. So the carbon dioxide, the basic production of carbon dioxide is you burn something and what comes out of is carbon dioxide. So like every time you start your car, the gasoline powered car, or every time you you know, turn on like your oven, gas burning oven, or anything like factories and everything, is producing a significant amount of carbon dioxide for our planet. So if that carbon dioxide level goes to the dangerous level, the carbon dioxide is a good molecule to trap the heat. It works like just the home insulation. So we put, like they put a lot of home insulation behind the walls, so when you heat up your home, the heat doesn't escape easily. The carbon dioxide works around Venus the same way. It doesn't let the heat go into space. So sunlight keeps warming up the planet, and then the planet warms like an oven and reaches to 900 degrees, which is not a survivable planet. So we don't want this to happen our planet, because why? Why we are so concerned about our planet? Well, yes, you're right. We don't have any other place to go. All right, so
we got a question from Kurt, and he asks, "Did you know they regulated vehicle exhaust decades ago, but not lawnmowers? As a result, a lawnmower today emits about 15 times much exhaust as a vehicle." I don't know if that's true, but that's crazy.
Yeah, I think there is a I was working on my lawnmower a couple of weeks ago, and I realized my not lawnmower, but another, like the gas-powered backyard tool, and it said that particular engine was confirming with the state of California emission law, but still they are using very old technology. I mean, they are using carbureted engines, and and especially as they get very old, the carburetor is not making an efficient the fuel and air mixture, and that is causing emission. And I can tell, yes, because like when especially these like the lawn guys are mowing lawns in the neighborhood, I can smell from the street. I can smell their exhaust. So they must be putting a lot of fumes. But I don't know. I think it's like a government's job to do something about these emissions.
Agreed.
Kurt
agreed.
has a very good point that yeah, we are so focused on cars, but we are omitting a significant issue with the small powered gas engines.
All right, we got another question from Lamia who asks, should life systems depend on oxygen? I mean, can't there be other forms of adaptation with support of other gases other than oxygen?
Absolutely. Oxygen is not the most important or necessary, the critical component for life, because when we look at even Earth, we don't need to search the other planets. In our planet, we know species that lives without the existence of oxygen, even sunlight. And like, for example, under sea, the deep enough, there are some species living without little or no oxygen and no sunlight. So when we say liquid water, also there are some species lives in very dry conditions too. But in general, when we look at for like life in the universe, we pretty much think, and this is very big generalization, that we put the liquid water and oxygen as a requirement, but those are not the critical for life. Of
Yeah.
course, the life can
It's
exist
just how we
without
know
these
it,
conditions.
right?
Yeah.
So we know that it works. We look for it to work like that, right?
You know, usually the third graders ask, are there people on other planets? They are not asking the question as like, is there life on other planets? They are asking whether there are people. So they always imagination as like people like us living on different planets. But we need to think that even like the mold is a living species.
Yeah, we might find jellyfish. Maybe there's some what do you call it? Jovian jellyfish.
I mean, even this is extreme. I'm talking about like mold. If find mold, then you find life on somewhere.
Yeah, so much. Anyway, so speaking of Earth Day, speaking of NASA, which is stuff we cover so often, Levent, a lot of people think that NASA just spends time sending humans to space, going to Mars, but it's done a lot for Earth, right? And for Earthlings like you and I. I don't know if you want to talk a little bit about that. I mean,
Sure.
granted, looking at Buzz on the moon is awesome, but what does NASA do for us?
Well, certainly, like rather than, of course, taking that great picture and initiating a great thing like Earth Day, these missions, the Apollo missions particularly, because the picture was taken during Apollo era, these missions contributed a lot of things in our lives, and we use them even today. And you may not think of even that we are using them today. For example, I mean, let me give you some examples of what the space missions, and they ask me all the time, like, why we are spending a lot of money to go into the space? Do we really need to spend that money? Well, if you think about the benefits of findings, for example, and I seen this actually the first the Velcro made by NASA.
This just blows my
NASA
mind.
engineers, yes, they used Velcros. So because the problem was the Velcro was first needed in the spacecraft, the Apollo spacecraft itself, because they had flight checklists, and the using clips to as a holder for the flight checklists was a little bit difficult. So they wanted a little bit more convenient and lightweight something, and they invented Velcro because it was so convenient. You just rip it off and put new one in.
What a simple solution.
That led using Velcros in all over the place, even like they need to stick something on their backpack, and here is Velcro. Velcro is invented for Apollo people and used now on every day. I don't know, I use it at home all the time. So great. So let's go to the next example. Well, you never thought about scratch-resistant lenses, right? And shatter-free glasses too. So they wanted to invent a glass which is hard to break and hard to scratch. Why? Because there are a lot of these things in space floating, and they may likely hit to their spacecraft's window. Because window is so fragile, it will break, it will depressurize the spacecraft, and it's not like airplane. You cannot just descend and save people. Well, your astronauts will die. So they wanted to make scratch-free and shatter-proof glass that we use in the windshields a lot, and also the glasses.
And now all of our cell phones too.
Oh, yes,
Scratch resistant.
exactly.
Even though it says scratch resistant, but in my experience, my screens all have scratches.
Do you know how many NASA patents inside the electronics inside is holding? And these wireless communication is one of them, actually. The wireless communication, the first long-range wireless communication was also at least like engineered and improved during Apollo missions. Why? Because there is no wired line to your Apollo spacecraft, so
Doing
you have
more
to
for Earth.
communicate like from long distance.
Speaking
The-
of the communicating, they used satellites to do that, right?
Yes,
And we use satellites to do a huge, really important thing on Earth.
exactly. And like the weather forecast. Well, we can real time monitor this data, and not only monitor, the forecasters are also modeling this and telling you what's going to happen tonight, tomorrow, even 10 days from now. That's with the help of all the satellite data, because they can see all the things in the air from satellites very well. So that data is collected.
That all this weather stuff is it's like a double-edged sword. I mean, you first of all get all this safety and wonderful benefit of knowing, hey, it looks like this is twisting. We could get a tornado or a hurricane, like what we have going on in the Pacific right now. But the other thing is those same satellites started noticing, hey, your temperatures on average are just going up year after year, and it's great that we get to predict things, but it also feels bad when you realize humans are kind of having a really negative side effect.
Yeah.
What we're doing on the Earth.
Kurt has a good question that I don't know the answer exactly. He says, when I was in school, they thought the oxygen was 21% in Earth atmosphere. Today, schools teach 18%. Did it change? Well, I don't know what is the average, and if it is just measured more accurately. But I'm sure, like, if you go to different places, the oxygen levels may vary. For example, if you go to forest, there will be more oxygen, the oxygen rich, and also with the altitude, it is changing too. But I don't know what is the generalization and the evolution of time. But certainly oxygen is not the dominant thing in the air. It is nitrogen. Nitrogen dominates the air we breathe in, and the oxygen is very small part. Well, if it was the other way, if the oxygen was much higher levels in the oxygen, in the air, then when we breathe, we would burn all of our lungs. So the oxygen is very important. You know the importance because, like, with the elevation, when you go to a mountain, the oxygen level changes slightly, and some people are really uncomfortable breathing at the altitudes.
Yeah, I mean, less atmosphere, less oxygen, less everything.
For example, if you go to like the observatory in Chile, some people are not able to breathe.
They actually like send you with oxygen tanks and stuff too, I think.
Yeah, it looks weird. You are going there with your support system.
I would say it doesn't seem comfortable. Speaking of comfortable, another huge thing that NASA has done for a little less for the Earth, because there's probably a lot of plastic in there, but certainly good for humans, and we're part of Earth.
Usually it doesn't go this way when you like. But certainly the memory foam, which became very popular a decade ago in mattresses, but it was actually first invented for astronauts, because when they are in space, the lack of gravity makes their like a sleeping pads very uncomfortable. So they needed something that when they
Oh.
lay on, it takes their body's shape, so
Mhm.
it can support. Because like when you have like very little gravity or no gravity in space, you can actually sleep at the tip of your maybe nose. I mean, your body
I
doesn't.
I'd have to say I don't really like memory foam
Yeah.
mattresses. I don't know. Some people are into that, but that's not my
Well,
jam.
what actually we use in mattresses are not the greatest quality memory foams too. I mean, there are like different grades, and some of them is just like a soft sponge. That's it. So I don't like either. Not my personal favorite. So here are solar panels. Well, this is very obvious because you have to produce electricity in space.
I think this is the biggest one for me.
You cannot just take a long extension cord and run it all the way to the moon. It would be cool, right? So you have to produce electricity, and all the electricity in space to your spacecraft comes from batteries and the solar panels. Solar panels most of the time charge your batteries, and especially with satellites. Well, satellites can operate 30, 40 years. They couldn't if they didn't have solar panels.
Yeah, yeah, true. And solar panels benefited Earth tremendously, right? That's clean energy. Well, to some extent, people like to leave out that solar panels do have lots of heavy metals, things
Yeah.
that are toxic. But
Yeah.
I mean, well-produced solar panels today,
Yeah,
clean energy.
it's free energy, but yeah, there is something with the production of these panels. Of course, like there are some like as Jim said, the poisonous chemicals and toxic materials to make
Mhm.
those. But when they are made, I don't know what the lifespan for a solar panel. But the biggest problem was, and there's still some improvement. Their efficiency is very low. So
Yeah.
when you get solar panel, you get I don't know, like 10 years ago they said they were only 12% efficient. So I would like to imagine how will be when they are like 50%, 60% efficient. I think
I
we'll
think
get a
like the
lot more of them.
maximum efficiency is somewhere close to like it's pretty low, right? The maximum efficiency might be 70% or something of the energy that hits a certain area. I don't remember, but that's like some elementary physics stuff
Yeah.
that you learn.
Yeah, efficiency is still not good enough for the solar panels, but they work. They work quite well, and they produce free electricity.
Yeah.
And there is actually if we can solve the efficiency problem, the solar energy is plenty of energy to support Earth.
Yeah, it would certainly be nice to not have to. I mean, you experience it if you're out in the country, you're away from the city. You take a deep breath, you can breathe. That air feels clean. You can feel it. You go into the city, you go near power plants, and you take a deep breath. You can taste all that oil and pollution. And if we just had solar panels
Yeah.
or other things, you know, it would be nice to have.
Every time
Yeah.
I drive around Houston, I see all the smoke coming into the air, and also the smell, the oil smell around it.
Yeah, yeah. It's just the air in Houston.
Yep.
Is something else. For sure.
Especially gasoline. The Houston smells gasoline in parts.
Definitely done a lot. We have some questions, stuff you might want to get to here, Levent. Brexton asks,
If there wind on the, is that what it is? If there wind on the planets, could they use wind turbines? Why not? Yes,
Yeah.
of course. They can use anything.
problem, and we're going to kind of touch on this in a moment, but places like Mars, the density of air is low. That we'd have to kind of modify our wind
Mhm.
turbines to
Yes.
some extent.
And they modified the drone, right? I
Yeah.
mean, it is not the same drone because the air pressure is low, and the helicopter.
I like Richard's comment a lot. We need to be smarter than a blade of grass.
It converts solar into sugars.
Yeah,
Correct.
plants. How dare they outsmart us? We're humans.
Well, if you look at it, a lot of species actually are they seem to be smarter than us
It's true.
in general. No offense to anyone.
Yeah, yeah. All right, we talked about Earth, but we do have to have some other quick news updates, Levent.
All
News
right.
updates. So let's
ready.
do it. You guys are going to guess where this is going. Levent's covering it up, but Ingenuity, huge update for Ingenuity, at least as far as I'm concerned, really big update. I don't know if you guys saw in the news, but on Monday, Ingenuity turned on its engines again and pressed go. They pressed play, and it flew. And as you guys might expect, I can bring that to you guys. We planned to bring
I
that
should
to
have
you.
brought my drone over here so I could just.
Yeah, you just
Fly
wanna
it.
fly this one. Are you ready to fly this one?
Yes.
Here we go. Okay, we can watch it fly. At least to some extent. I can't skip through this video, but you guys can see the blades come on here. There's no sound. I was really disappointed watching the news coverage of this that we were going to get some sound bites, but there it goes. Gets like 10 feet in the air, turns about 90 degrees. We're going to see it turn, and it goes back down. This is really cute. It has a little bounce. I want everybody to watch the little bounce. I don't know how good your connection or quality is, but when it goes back down, it has like the tiniest little bounce. Just cracks me up.
That was intended flight, right?
Yeah.
For this drone.
That's what they hoped. I mean, it tested. It worked. This is crazy because, I mean, it's like 1% the density of air on Earth, right? Here's a photo of that the drone took looking down. It has a really low-res camera on the drone, and you can. This is cool. You can see the shadow. Let me get rid of myself on here. This is really neat.
Yeah, the challenge with this drone is it is operated on a different planet's surface, which gravity is different, air pressure is different, so a lot of parameters are different. So that means these blades and the entire aerodynamics of the drone needs to be designed differently. So that's what it. Well, otherwise,
Yeah.
I mean, if you fly a drone on Earth, what's the big deal? Now kids play with drones all the time. But doing it on the different planet, from especially controlling from this far, is the challenge, the biggest
So
challenge.
crazy. So crazy. It's huge. I mean, the excitement is that, hey, drones work now. So we can send them to other places, easier places. It would be easier to fly a drone on Venus. The air is thicker. The blades work better. It would be easier on Titan because the air is thicker. I think the Titan's air density is like a little bit thicker than Earth's. I don't quote me on that, but I think it is. Venus, we obviously mentioned it earlier, way thicker. So cool. So congratulations. This is great news for planetary scientists and great news for Earth, right?
Absolutely,
And us.
yeah. And let's all celebrate Earth Day tomorrow.
That'd be
And
neat.
let's all try to find something to do about our planet. So that may be even as small as maybe picking a trash from your street. But yeah, please do something for your planet tomorrow.
Definitely. Yeah. Earth Day. Here's some celebratory fireworks since this is the best we can do. I don't have the source for this on the internet, but somebody on the internet made this, not us. I can say that much. Yeah. Happy. This is yeah. Happy Earth Day, right?
Happy Earth Day.
All right. I guess we're it. Anything
All
else?
right.
Levin?
We'll see everyone next week here.
See ya.